Let us see the solutions for Uttarakhand Public Service Commission, Deputy Superintendent of Police, Police Telecommunication, 2024 ECE question paper solutions, part 2. It contains questions from question number 31 to question number 60. Question number 31. Given direct sequence BPSK system used to transmit a voice signal which is sampled at 8 kHz. Sampling rate is 8 kHz and encoded bits are, it is an 8-bit PCM, 8 bits per sample. Available carrier frequency given is 1.9 GHz and the available bandwidth is 40 MHz. So since it is a direct sequence spread spectrum system, here chips are transmitted in entire available bandwidth. Chips are transmitted in entire bandwidth of 40 MHz. So let us calculate bit rate. Bit rate is 8 kilo samples per second and 8 bit per sample, that is 64 kbps. The bandwidth of BPSK system is 2 times of bitrate RB. 2 times of bitrate RB. For direct sequence spread spectrum system using BPSK modulation, now it will become chip rate 2 RC, that is 40 MHz. So from this chip rate RC is 20 mega chips per second. So generally for BPSK system it is bit rate. For direct sequence BPSK system it is chip rate. So chip rate is 20 mega chips per second and processing gain is, it is a ratio of chip rate to bit rate, 20 mega 20 into 10 power 6, and the bit rate RB is 64 kbps. So that is 20,000 by 20 into 10 cube divided by 64. Its value is 312.5. Spreading factor or processing gain is 312.5 and chip rate is 20 megahertz. So correct option is D. Next question. A transmission line having a gain of 10 dB and is feeding 1 watt of power to the horn antenna. The antenna is matched to the transmission line. What is the total power radiated? So given transmission line gain is 10 dB, power input to horn antenna, that is 1 watt, and in the question it has been mentioned antenna is matched, perfectly matched to the transmission line, implies no mismatch losses. Antenna is perfectly matched, so no mismatch loss. Reflection coefficient is 0 and assuming efficiency of antenna is 100%, that is ideal antenna. Ideal horn antenna, the power radiated will be that is feed power 1 watt. Correct option is C. Next question. So given characteristic impedance for a transmission line is 50 ohm. Character impedance given is 50 ohm in the question, and the input impedance of open circuited transmission line ZOC is 100 plus J 150 ohm, and in the question they ask to calculate the input impedance of short circuited transmission line. We know the relation square of characteristic impedance is equal to the product of input impedance of open circuit transmission line and input impedance of short circuit transmission line. So from this, ZSC is equal to Z0 square by ZOC, input impedance of open circuit transmission line. So characteristic impedance is 50 into 50, 50 square divided by 100 plus J 150. So this is 50 by 2 plus 3J. Now its value is 50 into 2 minus 3J divided by 4 plus 9, 13. On calculation, 7.69 minus J 11.54 ohms. This is the input impedance of short circuit transmission line. Correct option is C. Next question. A quarter wave transformer can be used for matching accurately. A quarter wave transformer is a transmission line of length lambda by 4, where lambda is operating frequency, and it is used for matching purely resistive loads. Correct option is B. This quarter wave transformer is not suitable for matching complex loads, that is inductive or capacitive loads. For complex loads, matching techniques like L network, stub tuners, Smith chart methods, etc. are employed. Next question. Aggie-Woda antenna has one driven element, one or more directors, and one reflectors. So this is driven element, one or more directors, and one reflector. And the length of reflector is 5% more than this driven element, and length of these directors are 5% less than the driven element. Length of reflector is 5% more than the driven element and carry capacitive currents, and length of director is 5% less than the driven element and carry inductive currents. In general, the length of reflector is 500 by f, where frequency is in megahertz and the length is in feet. For driven element it is 475 feet by frequency in megahertz. For director element 455 feet divided by frequency in megahertz. These are the values for reflector, director, and driven element in terms of feet. So correct option is Aggie-Woda antenna consists of driven element with a reflector and one or more directors. Correct option is A. Next question. The radiation field of antenna at a distance R varies as. Generally, the regions surrounding the antenna consist of reactive near field, radiating near field, or Fresnel region, radiating far field, or Fraunhofer region. The electric field or field varies as 1 by R in radiating far field, and electric field or magnetic field proportional to 1 by R square in Fresnel region, whereas in reactive near field, electric field is proportional to 1 by R cube. So correct option is the field of antenna at a distance R varies as 1 by R in radiation field. In radiating near field, it is 1 by R square, whereas in reactive near field, it is 1 by R cube. Next question. The voltage standing wave ratio lies in the range of. So correct option is D. VSWR lies in the range of 1 to infinity. The formula for voltage standing wave ratio is 1 plus mod gamma by 1 minus mod gamma, where gamma is reflection coefficient, ZL minus Z0 by ZL plus Z0, where ZL is load impedance, Z0 is characteristic impedance, VSWR is 1. So perfect matching. For perfect matching, no reflection losses. When VSWR greater than 1, mismatch exists. If VSWR is infinity, there is a complete mismatch between the load and the transmission line. So VSWR ranges from 1 to infinity. Next question. Select among the following the best application for vertical mast antenna. So this vertical mast antenna is used in radar, turnstile antenna used for TV transmission and for TV reception, Aggie-Wood antenna, dish antenna is used for microwave broadcasting. Correct option is A. A. Next question. Double minima method is used to measure. So it is used to measure voltage standing wave ratio, high voltage standing wave ratio, whose value greater than 10. Double minima method is a technique used to measure high values of VSWR. Here there are two minimum points. So this is one minimum point and second minimum point. VSWR is lambda g guided wavelength by pi into d2 minus d1. So d1, d2 are the points where minima occurs. Where lambda is g is guided wavelength, lambda naught is free space wavelength. So correct option is B. A coaxial RF cable has characteristic impedance of 50 ohm and capacitance is 40 picofarad per meter. So given characteristic impedance Z0 is 50 ohm and capacitance is 40 picofarad per meter, and find the inductance per meter. In the question, it has been given a coaxial cable where characteristic impedance Z0 is equal to square root of R plus j omega L by G plus j omega C. For lossless transmission line, R is 0, resistance is 0 and conductance per unit length is 0. Therefore, characteristic impedance Z0 is equal to square root of L by C. So from this, Z0 square into C is inductance per unit length. So L is equal to Z0 50 square into capacitance 40 picofarad per meter. So on calculation, inductance is 10 power minus 7 Henry per meter, that is 0.1 micro Henry per meter. So 0.1 micro Henry per meter. Correct option is C. Next question. The core refractive index N1 is 1.5 and clad refractive index N2 is 1.47, 1.50, 1.47, and numerical aperture. And the formula for numerical aperture is square root of N1 square minus N2 square, that is equal to sine of theta A, where acceptance angle theta A is sine inverse of numerical aperture. So first to calculate, given N1 N2 is 1.5 and 1.47, calculate numerical aperture 1.5 square minus 1.47 square, that is 2.25 minus 2.1609 square root of 0.0891. So the value of numerical aperture is 0.2985. Acceptance angle theta A sine inverse of numerical aperture, that is sine inverse of 0.2985, angle is 17.36 degrees, 17.4 degrees. Correct option is D. Acceptance angle to the fiber is 17.4 degrees. Next question. Graded index fiber has a core with parabolic refractive index profile. So graded index fiber has a core with parabolic refractive index profile. For a parabolic refractive index, the value of alpha is 2. Numerical aperture in the question it has been given as 0.2, and operating the core diameter is 50 micrometer, core radius is 25 micrometer, operating wavelength of 1 micrometer. So operating wavelength, core diameter, numerical aperture and parabolic refractive index profile, that is alpha is equal to 2 is given. In the question, he asked to calculate the total number of guided modes. So let us see the formula here. The total number of modes in graded index fiber is alpha by alpha plus 2 into square root of into v square by 2, where v is normalized frequency 2 pi a by lambda into numerical aperture, where alpha is 2 for parabolic profile, alpha is infinity for step index fiber, alpha is equal to 1 for triangular profile. So calculate the value of normalized frequency. Nu is 2 pi a is core radius 25 micro by lambda, so that is 10 power minus 6, 2 pi a by lambda into numerical aperture value is 0.2. So normalized frequency is 10 pi and total number of modes is alpha by alpha plus 2, 2 by 2 plus 2 into v square by 2, 10 pi square by 2. So its value is 986.96 by 4, that is 246.74. So total number of modes are 247. Correct option is B. And this is a formula to find the number of modes in graded index fiber and to find the normalized frequency. Next question. The value of fiber core diameter for a single mode step index fiber which has mode field diameter, given mode field diameter is 11.6 micrometer and normalized frequency is 2.2. A is a core radius. So 2 times of core radius is core diameter. In the question, he asked to calculate the value of core diameter. So the formula for mode field diameter is, for single mode fiber, mode field diameter is 2a into 0.65 plus 1.619 divided by v power 3 by 2 plus 2.879 by v power 6, where v is normalized frequency whose value given in the question is 2.2. So substitute the values in the given in the formula, mode field diameter formula, that is 11.6 micro 10 power minus 6 is equal to 2 times of a 0.65 plus 1.619, normalized frequency is 2.2 whole power 3 by 2 plus 2.879 by 2.2 power 6. Now it is 2a 0.65 plus 0.4949615 plus 0.025392. 2a is core diameter is equal to 11.6 micrometer divided by 1.1715. So that is 9.90183 micrometer. So 9.9 micrometer. Correct option is C. So let us see some more points related to mode field diameter. So this mode field diameter is determined by the numerical aperture and cutoff wavelength of the fiber and is related to the diameter of fiber core. In general, mode field diameter is greater than physical diameter of the fiber core which means that some optical power is always guided by the fiber cladding. This mode field diameter of single mode fiber refers to effective diameter of the optical fiber distribution in the fiber. Larger the mode field diameter, more light spreads into the cladding, reducing fiber tolerance to bending. Smaller the mode field diameter results in tighter confinement, reducing dispersion. And one more formula for calculating the mode field diameter is approximately 2 lambda by pi into square root of n1 square minus n2 square. So this is a problem or question related to mode field diameter of single mode fiber. Next question, helical rays. Skew rays are not transmitted through the fiber axis and does not cross the fiber axis. These skew rays follow helical path along the fiber. Skew rays are difficult to track. Its the path of skew rays is difficult to track as this skew rays does not lie in a single plane. So there is one more rays, meridional rays, bounded meridional rays and non-bounded meridional rays. These bounded meridional rays propagate along the fiber axis within the core. These rays are refracted out of non-bounded rays are refracted out of the core fiber. Meridional rays are confined to a single plane. These meridional rays are confined to a single plane. It is easy to track its path as it travels along the fiber axis, whereas meridional rays enter into the fiber through its axis and cross the fiber axis at each reflection. So let us see the difference between skew rays and meridional rays. These skew ray paths are difficult to track because they do not lie in a single plane. The paths of meridional rays are easy to track because these lie in a single plane. Meridional rays are classified into bounded and unbounded rays. There is no such classification for skew rays. Skew rays tries to follow helical path along the optical fiber. Meridional rays are confined to fiber axis. Meridional rays crosses the fiber axis, whereas skew rays doesn't cross the fiber axis. So it does not cross the fiber axis, whereas meridional rays crosses the fiber axis. So correct option here is the skew rays follow helical path, not circular, not parabolic, not elliptical. Correct option is A. Next question, which optical devices are applicable for routing signals from one waveguide to another waveguide? So let us see what is optical coupler, optical combiner and optical splitter. So optical coupler, it is a passive device used in fiber optic system to split or combine the optical signals. It allows multiple optical fibers to be connected, enabling signal distribution or merging. So the given diagram is optical coupler. So different types of optical couplers are directional couplers, star couplers, tree couplers, trapped fiber couplers. Whereas optical combiner combines multiple optical signals from different fibers to a single fiber. Optical splitter splits single optical signal into multiple signals, distributing it to the multiple fibers. So let us see the differences between optical coupler, combiner and splitter. Combines multiple optical signals into single one. Optical splitter splits one optical signal into multiple outputs, whereas optical coupler is combine or split optical signals from different fibers. So this combiner and splitter are unidirectional, whereas coupler is a bidirectional. As per the question, the correct answer is B, optical coupler. These devices are used for routing signals from one waveguide to another waveguide. Correct option B. Next question, maximum angle to the axis at which light ray may enter the fiber in order to be propagated is known as. So correct answer is acceptance angle. Acceptance angle is a maximum angle at which light can enter into the fiber and transmitted along the fiber through total internal reflection. So larger the acceptance angle, more will be the light coupled into the fiber. So the relation between acceptance angle and numerical aperture is equal to sine of acceptance angle. So let us see this critical angle definition also. Critical angle is angle of incidence where angle of refraction is 90 degrees. Critical angle is a minimum angle of incidence for which light grazes along the surface of the boundary. So this is core refractive index is N1, cladding refractive index is N2, where core is more denser medium than cladding. Incident ray having angle of inclination theta I, and this is a refracted ray. If angle of incidence is equal to critical angle, if angle of incidence is equal to critical angle, then angle of refraction is 90 degrees. The wave grazes along the boundary between rarer medium and denser medium. No reflected component here. So here also no reflected component, only refracted component. If angle of incidence greater than critical angle, if theta I greater than theta c, then there is no refracted ray. Entire signal is completely gets reflected back into the same medium, that is denser medium. So these are the three conditions. When angle of incidence less than the critical angle, angle of incidence is equal to critical angle of incidence greater than the critical angle. So according to the Snell's law of reflection, n1 sin theta 1 is equal to n2 sin theta 2. If theta I is equal to theta c, if theta is equal to theta c, then critical angle is sine inverse of n2 by n1, because theta 2 is 90 degrees, sine 90 is 1. So here the maximum angle to the axis at which light may enter into the fiber in order to be propagated in the fiber is known as acceptance angle. Correct option is D. Next question. Name the scientific principle behind the working of optical fiber. Optical fiber works on the principle of total internal reflection. So that is optical fiber works on the principle of total internal reflection. That is, when a light ray strikes at the internal surface of optical fiber with incidence angle greater than critical angle, then incident ray reflects in same medium and this phenomenon gets repeated. This is called total internal reflection. Correct option is C. Total internal reflection of light. Next question. Fiber cable used for fiber to home installation. So that is single mode fiber. Fiber cable used for fiber to home installation is single mode fiber. So fiber to home installation uses single mode fiber to provide high speed internet access to homes and businesses. Single mode fiber is a type of optical fiber cable that has small core size and the signal can travel for longer distances. Single mode fiber has several advantages. One is long distance transmission, high bandwidth, low attenuation, fast transmission speed, limited data dispersion, and limited external interference. Correct option is A. Next question. Which element will be the second from the bottom of stack if the following operations are performed in the order? So let us see about push and pop operations. In computer programming, this push and pop instructions are used to manage data on the stack, where stack is a data structure that follows last in first out principle. So stack follows last in first out principle. So push and pop operations are used in stack. So in stack all operations takes place in the top of the stack. So what the push will do is push adds data onto the top of the stack, while pop removes data from the top of the stack. So let us see the question. A instruction is executed. Push A instruction is executed. The element A will be on the top of the stack. If push B is again executed, B will become on the top of the stack. Push C is executed, C will be on the top of the stack. And then pop operation, the element on the top of the stack is removed, C will be eliminated. Now B will become on the top place. Again pop operation, A will be on the top. Next push D operation, so D will be on the top of stack. Push E operation, E will be on the top of the stack. Now as per the question, what element will be the second from bottom of the stack? Second from the bottom of stack if the operations are performed in this sequence. So the element from the second place is D. So the correct option is A. Next question. A silicon chip that contains ALU, a register circuit, and control unit is microcontroller. So microcontroller is a small computer on a single chip that controls. It is a small computer on a single chip that controls specific functions in a device. It also known as embedded controller. Microcontroller is an integrated circuit that contains Microcontroller is an integrated circuit that contains processor, memory, I/O peripherals on a single chip. So correct option is C. So one more definition for microcontroller is a small computer fabricated on a single silicon chip that is intended to carry out a specific function of embedded system. Next question. What will be the output of the following C language code? So here the program is given main int a3 of a array of elements is given a of 3, so that is 1 2 3. Print of %d a1 comma a2. So the elements in a1 comma a2 is 2 comma 3, so that is a of 0, a of 1, a of 2. These are the elements stored in an array, and the elements are 1 2 3. Now print a1 comma a2. So print a1 and a2. So a1 a2 contains memory location a1 and a2 contains 2 and 3. Correct option is D. Next question. Which of the following is an example of system software? So generally software is classified into two types. One is system software, and then this is a broad classification, application software. System software and application software, which is a broad classification. System software refers to low level software. This system software is an low level software that manages and controls computers hardware and provides basic services to high level software. The two main types of softwares are system software and application software. System software is a type of computer program that manages computer hardware and applications. Various system softwares are operating systems, device drivers, firmware, utility software, and bootloader, whereas application software is designed to perform a specific task for the user or software that performs specific functions for a user, such as word processing, gaming, and web browsing. It is designed to perform a specific task for the user, or this application software is a software that performs specific functions for the user, such as word processing, gaming, or web browsing, etc. So correct option is none of the above. This Microsoft PowerPoint, MS Word, Adobe Reader, these are the examples for application software, and the example for system software in the question is none of the above. Next question. A process through which there is a direct transfer of data between main memory and I/O device without intervention of CPU is called direct to memory access. So DMA. So direct to memory access. This DMA controllers transfers data between I/O devices and system memory without significant CPU involvement. So this DMA stands for direct to memory access, which is a technology that allows hardware devices to transfer data directly to and from to the memory. Hardware can transfer data directly to the memory or from the memory without involving CPU, thereby improving the system performance and efficiency. Correct option is C. So DMA, direct memory access, where the input device or output device can share the data between main memory without the intervention of CPU. Question number 54. So the following program has written on RISC processor, reduced instruction set processor computes load R1 comma A, load R2 comma B, load R3 comma C, multiply R1 comma R2 comma R1 comma R1 comma R2. So be careful, it is not R1 R2 R3, it is R1 R1 R2. Next, store x comma R1. So let us see these instructions. Load R1 comma A loads the value of memory address A into the register R1. Load R2 comma B loads the value from memory address B into the register R2. Load R3 comma C loads the value from memory address C into the register R3. Now multiply R1 comma R2. If it is R1 R2 R3, multiply the values of registers R2 and R3 and stores the result in R1. Store x comma R1. Store the value from register R1 into the memory address X. In the question it has been given multiply R1 R2 and store the result in R1. So correct option is and store x comma R1. The value store the value from register R1 to memory address. So therefore x contains R1 multiplication with R2. X is equal to A star B. Correct option is D. Next question. Which of the following represents correct syntax of writing comments in Python programming? So the comments in Python programming is written by using hash symbol. So correct statement is hash written comments. Correct option is B. Next question. Telnet command in Unix is used to connect to the remote machine. To connect with the remote machine. Telnet command in Unix is used to connect with the remote machine. This telnet command in Unix is used to connect a remote server and interact with it through the command line. This telnet command in Unix is used for establishing remote connection to the another computer or a network device over the telnet protocol. Question 57. Which of the following is not a type of Unix operating system? So let us see different operating systems in Unix. So general purpose Unix operating distributions are Ubuntu, Debian, Fedora, CentOS, Red Hat Enterprise Linux, OpenSUSE. Lightweight Unix distributions are Linux Lite, Ubuntu, Puppy Linux. Specialized Unix distributions are Kali Linux, Parrot OS, Raspberry Pi OS, Alpine Linux. Enterprise and cloud focused Linux distributions are Oracle Linux, Amazon Linux and Rocky Linux. So let us see here which is not a Linux operating system. So this Red Hat Enterprise is a Linux operating system. Red Hat Enterprise, Fedora, Ubuntu, but this Sun system is not a Linux operating system. Correct option is A. The total number of distinct characters that are represented in ASCII code are. So ASCII stands for American Standard Code for Information Interchange. It is a standard character encoding used in telecommunications. ASCII codes are used to represent alphanumeric data. This ASCII is 7-bit character set and contains 128 characters. Correct option is C. This ASCII is a 7-bit code. ASCII is a 7-bit code and it can represent 128 characters. It currently defines 95 printable characters including uppercase letters and 26 lowercase letters, 10 numerals and 33 special characters including mathematical symbols, punctuation marks and space characters. Question number 59. The opcode of an instruction consists of, so instruction in a computer language consists of both opcode and operand. Opcode specifies the operation. Opcode specifies the operation to perform and the operand specifies the data on which operation is performed. This opcode are operation code is a single instruction that a CPU is capable of carrying out. So correct option is B. Opcode of an instruction represents operation of an instruction. Question number 60. Which of the following is property of RST 7.5 interrupt? So before seeing this, let us see the interrupts of 8085 microprocessor. So 8085 microprocessor consists of 5 hardware interrupts, that is INTR, RST 7.5, RST 6.5, RST 5.5 and trap. This RST 4.5, that is trap, vector address is 0024H and vector address of RST 7.5 is 003C. For 6.5 0034H, for RST 5.5 002C. For trap, vector address is 0028. This trap is non-maskable. The trap interrupt is non-maskable interrupt generated by an external device such as power failure or hardware which cannot be disabled. Whereas this RST 7.5, RST 6.5, RST 5.5, these interrupts are software interrupts, and INTR, it is a maskable interrupt generated by external device such as keyboard or mouse which is having low priority, and this interrupt can be disabled. Trap is having highest priority, INTR is having lowest priority. Both are hardware interrupts. This 7.5, 6.5 and 5.5, these are software interrupts. It is an trap and INTR are hardware interrupts. Similarly, in 8085 there are 8 software interrupts, RST 0 to RST 7, and the vector address are mentioned in the table. For RST 0, vector address is 000H, and for 7 it is 0038H. For RST 4 software interrupt, it is 0020H. So like this. So in the question, which is the following is a property of RST 7.5? RST 7.5 is having second highest priority after trap, and it is a software interrupt which is maskable. Its vector address is 003CH. So correct option is D.